So this video is going to walk you guys through Unit 3, Level 3, Part 2 notes. And the main objectives of this level is all about finding the measures of central angles, minor and major arcs, and then arc lengths of a circle. Okay. There's a lot of definitions and words in here, but I'm going to highlight the three main things you would need to know. And these properties in this table are what's going to help us calculate some of these measurements that it's going to ask for. So one of the first things you need to know is that the sum of the measures of the same central angles within a circle with no interior points in common is 360, right? So ultimately that just means that it's 360 degrees around a circle. And I know a good number of you guys knew this prior to my class. Okay, so we know the rule of 360. Okay, another rule that's going to be important is this property of minor arcs. They equal the measure of its central angle. So minor arcs equal the central of their, or equals the measure of its central angle. And then major arc is 360 minus the measure of the minor arc. Okay, but the key thing of this property, this rule, is that remember when we name major arcs, we use 3 points, right? And then to get its minor arc, I just use the 2 points on the end. So the minor arc of this major arc is just CF. Okay, and I know it's a minor arc because if you notice, we only have 2 points then. 2 arcs are congruent if and only if their corresponding central angles are congruent, right? So that's just a property based on logic. If their central angles are equal, then obviously the arcs are going to be equal. And then last but not least, the arc addition postulate. So this is very similar to the other postulates we had. And essentially what it says is if I add the measures of 2 small arcs, it gives us the measure of the large arc. Okay. Over here in example number 1, we find the measurement of these angles. Okay, and then example number 1 is all about the rule that sum of central angles equal 360. Okay, so it's asking first for angle SCT. That's this angle over here. If you look at this diagram, they give us that angle SCR is 45 and angle UCT is 60. To find SCT, I noticed that these 3 angles equal 180 degrees, right? So I would just do 180 minus 45 plus 60. Okay. 180 minus 105, which gives me the final answer of 75 degrees. Okay, then angle SCU, I just add SCT and TCU, so that's 75 plus 60, which gives me 135 degrees. Okay, and then angle SCQ. So the original diagram, I'll take that out, shows that this full angle is 90 degrees with that little box, so I don't need to do any calculations whatsoever. And then QCT, I just add this 90 degrees and the 75 together. and then that gives me 165 degrees. Okay. So that's the idea of central angles all equaling 360. If you check my math, we add all these angles together, 60 plus 45, or 60 plus 90 plus 75 plus whatever is left over, it all will equal 180 degrees. Okay. Now let's look at example 2. In example 2, you're going to be solving for a mix of central angles, minor and major arcs. And I'm going to categorize them just so you're familiar with. So central angles, we'll put that in a maroon color. I'll put all the minor arcs in green, and then I'll put all the major arcs in this dark blue color. Okay, so I'll do central angles in this color, minor arcs in green, and then I'll do major arcs. Now, oftentimes I have people ask me, how can you tell the difference of minor and major arcs, or what kind of calculations you have to do? I just take a look at the notations. It didn't show up on my PDF, but numbers 1, 3, and 5, these are all measurements of central angles because your paper should have the little angle mark there. Okay. Numbers 2, 4, and 6 are all minor arcs because if you notice, they each only have 2 letters naming them. And last but not least, 7, 8, and 9 are all major arcs because they require 3 points to name them. Okay. In example 2, they don't actually give us values for the angles, but knowing all your properties of angles, we could solve for them. Okay. And I could do that by first solving for x and then plugging them in to get actual values for the angles. I noticed that these 3 angles all together, they form this straight line, so I know that the sum of these angles is 180 degrees. So I would do 4x plus 15x plus 3 plus 7x minus 5 equals 180. Let me combine like terms, so that's 4x plus 15x plus 7x. So that's going to be 16x. And then we have 3 and negative 5. That's minus 2 equals 180. Using inverse operations, you're left with 16x equal to 182. And then you get, not 16x, my bad. If you add all those constants together, it's actually 26x. There we go. So 26x, and I get x equals, let's see, 182, so 182 divided by 6. Pretty sure that's 7, but I'm verifying on my calculator right now. 182 divided by 26. Yep, it's 7. Okay, so now that I know x equals 7, all I do is plug it in to find these angle measurements they're looking for, right? So angle ERD, that's just 4 times 7. That gives me 28 degrees. Okay, measurement BRC, I'm going to make sure these are color-coded so you guys could differentiate them. Angle BRC, that's just 7 times 7 minus 5. And that should be 44 degrees. Okay, I think this is the wrong color. Yeah. And then last but not least, angle ARE. So angle ARE, even though it doesn't have an algebraic expression to help us solve for it, I do know that it's vertical to angle BRC, which you already solved for. So this is equal to 44 degrees as well. And our reasoning for that is because it's vertical to angle BRC. Okay, so those are the measures of our central angles. Now, let me change the color to signify the measures of the minor arcs. So we have arc DC. So let me clear this out. Okay, and then according to the definition of, or the property of minor arcs, we say it equals the measure of its central angle, right? So DC just equals the same thing as what this equals. So that's just 15 times 7 plus 3. If I double check my math on that, 15 times 7 is going to be 105 plus 3 gives me 108. So arc DC is equal to 108. Okay, and if you notice, the measurements are actually in degrees as well. Arc AB, that's this one right here. And if you notice, arc AB is minor arc, and so it's the measurement of this angle. You take a look. Its central angle is angle BRA, and it's a vertical angle to this angle over here, so that means these two would be equal. And so to get the measurement of BRA, all I have to do is add angle DRC and angle DRE. Okay, to get me arc AB. So that's angle DRE plus angle DRC. We said DRE, that was up here, number 1, that's 28 degrees, plus DRC was over here, was 108. So that will give you the answer of 136. Okay, and then last but not least, arc BD. That's the sum. Let me clear this off so it's easier to see. Arc BD, that's this arc right here, is going to be the sum of these two smaller angles over here. So that's angle DRC plus angle CRB. DRC we already said was 108 degrees. CRB was 44 degrees. So ultimately, arc BD is going to be 152, because it's the same as the measure of its central angle. Okay, so we just used, so we calculated central angles, minor arcs, and now our last calculation for these examples are going to be calculating the major arcs. So I'll do this in dark blue so you could see the difference of all of them. We need to find arc, oops, my bad, arc EDB. So that's this arc right here. If you take a look, this arc is half of this circle. So all I need to do is find what half of 360 is, since the full thing is 360, and that's just 180. You could also use the rule of the fact that it's a semicircle. Okay. Next, we have arc DCA, right? And if you look back at the notes, it said that a major arc is 360 minus the measure of the minor arc. So arc DA is the minor arc. So I would just do 360 minus, where's DA? Arc DA, that's over here, right? And DA is just going to be DRE, that was 28, plus whatever was vertical to angle ERA, and that was 44. Right, so that's what makes up DA. So that's 360 minus 72. Let me plug that in real quick. That's 288. Okay, and then last but not least, we have to find arc DAC. That's this large arc over here. So DAC, arc DC is the minor. So I just do 360 minus the measure of arc DC, and we said arc DC was just 108, which gives us 252. Okay, so there are the calculations for finding central angles, minor and major arcs. Now the last is finding the arc length of a circle, right? So what all we did was find the measure of the arcs and the measure of their central angles. And there's a difference between finding the measure of the arc versus the length of it. And when we think about arc lengths, what we truly think about is this idea that arc length is a part of a circle and its length is a part of the circumference. So when we think about measures, it's really just related to the angles, but when we look at the lengths, it's related to circumference, right? The perimeter of the circle. And they give us this formula for arc length, which is x over 360 times 2 pi r, okay, where x is the degree measure of the arc, okay? And this is just a straightforward equation that you plug values into. Okay, it says the diameter of circle D is 18 units long, so I'm going to label that in the diagram. So we know that this is 18. Find the length of each arc for the given angle measure. Okay, so I'm just going to use this formula. So I need to find the measure of arc LM, and the way I do that is get degree measure of the arc. So LDM is 100 over 360 times 2 times pi times our radius in this case is going to be 18, or not 18, 9, since 18 is the diameter. And I would just plug this into the calculator. you could either use the pi button or you could estimate this to be, you can estimate pi to be 3.14. Those of you who want to keep it in terms of pi, you can, but it look a little awkward because you're going to get a decimal from this fraction anyways. But if I plug all of this in, give me a moment, this is what I get. I got about 15.7 for this first one. Okay, and I'll say 15.7 units. And then for number 2, our KLM, if measurement of KDM equals 160. So that would be 160 over 360 times 2 times pi times our radius was 9. Just plug all of that into the calculator. I'm going to estimate pi to be 3.14. So 160 divided by 360 times 2 times 3.14 times 9. I got about 25.1. I'll just round it to the nearest tenths. There we go. Okay, so it looks a lot more complicated than it truly is, merely because you're most likely going to be getting decimals for most of your answers for arc lengths. But there are the major concepts in Unit 3. Stay safe and stay healthy, you guys.